Hello friends, welcome to EC Academy. Today we are going to learn one of the most crucial steps in making silicon chips, which is known as oxidation. First, let us understand the basics. We use silicon a lot in most of the electronic devices, but this silicon alone is not sufficient. We need a special layer to protect the silicon and to control where the current flows. So, in electronic devices, silicon alone is not sufficient. Along with this silicon, we need a special layer which protects the silicon, and also this special layer will control where the current flows. The special layer is silicon dioxide, which is SiO2. This silicon dioxide plays a very important role in making silicon integrated circuits. Why? Because it acts as an insulator, which means it stops the current from flowing where we don't want the current to flow. And also, it has a passivating property, which means it makes the surface stable and reliable. So growing this silicon dioxide is very much essential because it has two important functions. First one, it acts as an insulator, which means if we are having two conduction layers, it will act as a primary barrier to isolate these conductive layers, and also it will block the current movement where we don't want the current to flow. The second function is that it has a passivation property, which means it chemically and electrically protects the silicon layer from impurity, which makes the surface stable and reliable. Now, how do you make the silicon dioxide layer? This process is called as oxidation process. In this oxidation process, first we'll take the silicon wafer and heat the silicon wafer. Now, this heating is not done in normal air, but we heat this silicon wafer in a special oxidation atmosphere. This means we surround this silicon with either oxygen or water vapor. When we heat the silicon in this atmosphere, a chemical reaction happens. Due to this chemical reaction, the silicon gets consumed and a layer of silicon dioxide is formed on the silicon wafer. So this process involves heating the silicon wafer under the oxidation atmosphere, due to which the chemical reaction happens and a layer of silicon dioxide is formed on silicon wafer. Now there are two common methods to do this oxidation. Method number one is called as wet oxidation. As the name suggests, wet means water vapors. These water vapors are available in atmosphere, and these water vapors are passed through the silicon, which is heated at 900 degree to 1000 degree centigrade, and due to chemical reaction a oxidation layer is formed over a silicon wafer. One of the major advantage of wet oxidation is the process is faster and a thick layer of silicon dioxide is formed. The second method is dry oxidation. The dry oxidation uses pure oxygen as oxidation agent. Since we are not using any water, we need more heat. So this process requires higher temperature around 1200 degrees centigrade. So the advantage of dry oxidation is it produces denser and high quality oxide layer. It is slow, but quality is best. Now this concept is very interesting. You need to remember the oxidation layer grows up and down, which means when oxidation layer grows, it will not just sit on the top of the silicon layer, but also grows inside the silicon layer, which means it grows above the original surface of silicon, and also it grows below the original surface of silicon. It is just like a popcorn. When it pops, it gets much bigger. So here you need to remember the SiO2 has roughly twice the volume of silicon it has consumed. So 1 unit of Si consumed will have 2.17 unit of SiO2 created. So if you look at the structure of N-channel MOSFET, you can see that field oxide, which is projecting upwards and downwards on the P substrate. So this is the silicon wafer on which the silicon dioxide is formed. From this structure, we can understand that it will not just grow above the surface, it will also dig into the surface and it will grow below the surface. Now let us quickly revise what we have learned today. The oxidation process creates silicon dioxide layer, which is great insulator. It is backbone for IC fabrication, essential for insulation and passivation. There are two methods for oxidation process. Wet oxidation, which is fast and it will produce a thick silicon dioxide layer at 900 degrees centigrade. We have dry oxidation, that is slow process, which will produce dense and quality silicon dioxide layer at 1200 degrees centigrade. Finally, the oxidation grows above and below the silicon surface and it has twice the volume. I hope this concept is crystal clear to you now. If you have any doubts, please comment below and I will answer them. Thank you.